Okay, it's about 5 after, so we will get going. So this webinar is on interference mitigation in the unlicensed band for particularly for StarPlus and for EION's products that operate in the 5 gigahertz unlicensed band. I'll just give a brief overview of what we'll be discussing today. So there'll be an introduction on co-channel interference and different types of co-channel interference, namely CSMA-CA and TDMA, and then go into a little bit more detail on rigid timing and dynamic timing with TDMA. And then we'll talk a little bit about adjacent channel interference, and then finally we'll close with a little bit of detail on EION's methods for dealing with all of these different types of interference in an unlicensed band. The presenter today is Dejan Beznek, who is EION's Director of Engineering, and I'm going to hand the control over to Dejan right now to proceed with the rest of the presentation.
Hello? Can you hear me?
Yep, we can hear you. So everyone in the everyone's on listen-only mode, so they won't be able to write back, but won't be able to talk back, but they can write messages.
Okay, sure. Hello, welcome to today's webinar. As Richard pointed out, my name is Dejan Beznek. I will be your host for today. I will talk a little bit today about how we are dealing with interferences, which is a very hot topic in an unlicensed band, which is not regulated, and it's actually there you are exposed to almost anything you can imagine. So the techniques that were usually used in the licensed bands do not necessarily translate directly to what we encounter here. So, let me see. Okay, this is the first slide. So I will be talking about co-channel interference, and I will be talking about adjacent channel interference. Co-channel interference are the ones that you can encounter on the same channel as you are, while adjacent channel interference are spurious emissions from adjacent channels around you. So let us first dig a little bit into the co-channel interference. Basically, any system operating in an unlicensed band, here we are talking about 5 gigahertz band and not about 2.4. Basically, this band under the FCC, it spans from 5.725 gigahertz to 5.875 gigahertz, but in some countries this is more restricted, or it's different interval, almost anywhere between 5 and 6. For example, in India, the unlicensed band is only 50 megahertz wide. It's from 5.825 to 5.875, which is much less than under the FCC rules, for example. So what systems that we can actually encounter in this 5 gigahertz band that are potential interferers, potential source of interference to us? First group are CSMA-CA systems, which support collision avoidance. Those are basically 800.2.11 systems. Most of you know them under the name Wi-Fi, either A mode, N mode, doesn't matter. Basically, high majority of systems deployed in an unlicensed band are of this type. And the biggest reason for that is because it's the cheapest, but it has lots of drawbacks. Then another one that we can actually encounter there is TDMA system with rigid timing. Those are, for example, samples from 802.16 standard. Most of you know them under WiMAX, either 16D WiMAX, 16E WiMAX. It really doesn't matter. The important part is that they are rigid in their timing, so and that is ensured either through self-synchronization, GPS synchronization, maybe even P2P 8588, but their downlink and uplink is fixed and synchronized in terms of when they can start transmitting, when they need to start listening, and so on. And those intervals are always of the same width and with the same frequency, and they do not change over time. Then you have TDMA systems with dynamic timing. One such example is, for example, EION's product line StarPlus. We are not claiming that we are the only ones that have implemented this, but our system falls under this category. Then, what is basically how we are approaching this co-channel interference mitigation? The most important part of this is our flagship TrustLink technology. TrustLink is basically a variant of TDMA. It's implementation of TDMA with the following most notable characteristics. It has dynamic polling of nodes. This gives you a great advantage over, for example, CSMA systems. Wi-Fi is notoriously bad when you have more CPEs connected to one access point where there are hidden nodes that cannot talk to each other. So all sorts of problems that come from the CSMA. But that is dealt with under the dynamic polling of nodes. But other TDMA systems can handle that as well. Where we are really specialists, that we allow for both dynamic cadence and variable time slots per subscriber retries. This means that we can change the frequency of bursts, but we can also change the width of the burst. So we can handle basically both, and number of retries, of course. Now, let us go a little bit deeper into what happens with StarPlus systems when it encounters each of those different types of systems. So, for example, first, what happens if we encounter some Wi-Fi system, CSMA-CA system? Basically, TrustLink algorithm ensures that StarPlus is constantly searching for the gap in the spectrum. And it aggressively seizes every opportunity it gets. So it also exploits the time available by optimizing the number of slots used to transmit and receive messages. While StarPlus, for example, is transmitting, see, as I said, we jump on every gap in the spectrum. Where there is a gap, we can use it for transmission. And while StarPlus is transmitting, CSMA-CA system will, by definition which is collision avoidance, they will go into random backoff. And with that, they will miss even more gaps during which they could transmit. So performance of the StarPlus system will be much less degraded when two systems collide. Let's say StarPlus together with collides with the CSMA system. The performance of StarPlus is much less degraded because we are much better in amount of opportunities we take advantage of when we can transmit and when the other system transmits. And that actually even enhances over time, because more gaps we see, more time CSMA spends in backoff, and so we are clearly winning the battle between these two. Then, now a little bit trickier, sorry, I jumped one. Now a little bit trickier part. Let's say the StarPlus encounters the co-channel interference from the TDMA system with rigid timing. Those of you that are familiar with, let's imagine you encounter another, let's say, WiMAX system. And let's take hypothetical case that we have 60-40 TDD split. So TDMA system with region timing spends 60% of time in downlink when the base station is transmitting, and 40% of time in uplink when base station is in receiving mode. At that time, CP is transmitting. But as you can see in the picture below, those width of those bursts and frequency of those bursts is completely fixed for the TDMA rigid timing. They cannot change over time. Synchronization ensures that transmission always begins at the same time, and the time interval dedicated to uplink is always the same length, and so on. So no surprises there. What then happens? TrustLink algorithm ensures that StarPlus would transmit only while offending system is not transmitting. Due to its dynamic cadence and variable slot assignment, it can actually accommodate both transmitting and receiving during to 40% of time while offending system is not transmitting. So what we actually do, on one hand, we recognize, yeah, the other guy is shouting. They're shouting really loud for that 60% of time interval. And we do not want to enter the shouting contest, because if both our system and the offending system are shouting at the same time, then both lose. Nobody wins from that unless you have much higher taste power. But you know, even in the unlicensed band, one of the few regulated items there is the highest transmit power that you can do. So none of those systems can go much higher above the other one, right? Since we are both limited by regulations, how much we can transmit. So you cannot win the shouting contest by just raising the transmit power higher and higher and higher. So what then we do? We say, okay, if our algorithm is adaptive, we can learn from the conditions in the field. If we find out that, okay, for 60% of time the other system is transmitting, then there is a gap of 40 and then transmitting again. So we try to squeeze our operation inside that, let's say, quiet period when the offending base station is in receiving mode. And what we do, we actually squeeze first our transmission at the beginning of the other system's quiet period. You can just observe the graphics here, so it will be more clear what I'm talking about. And we also squeeze in the same interval also our receiving mode, because if we would be receiving when other system is transmitting, then this would mess with our CPE uplink, which also would not be fine, right? So we are fitting everything inside that silent period. If that would be static and independent, then of course you would say, okay, but your utilization is then much lower. You are basically bound into that 40% and you will be always utilizing less than the other system. But that's basically not the case. What happens here? The last paragraph is the key here. Since StarPlus would transmit only in starting period of rigid TDMA system receiving, it will actually prevent rigid TDMA system CPEs from properly communicating to their base station. You know, when we are transmitting, we have higher power than the CPEs from the offending system when they are transmitting. So we are causing quite some interruptions to their CPEs, which in turn leads to some of the offending system CPEs to start disconnecting, and by increasing the error rate on those CPEs, that offending system also decreases its transmissions in the downlink, because then there are not that many CPEs anymore asking for information to actually transmit something to them. So this means that they will not be transmitting for 60% of time anymore. They will be transmitting for maybe 50%, 40, 30, 20. It all depends on the condition. But they will definitely lose the amount of time they can do transmission. So our downlink interval would actually be increasing beyond capabilities of those 40. It will be more and more and more. And of course, we will never be able to utilize everything, because if their two systems are colliding, then both will bear some scars. But what I'm saying here is that we will be able to make the best out of the bad situation, and we will grab more than what you would expect to be possible there, and the traffic that we are managed to pull through that would be, let's say, quite stable, and connections will be quite stable, because since we are always trying to fit ourselves in the position where the spectrum is quite clean, we actually are able to maintain quite stable connections and quite stable throughput. While, for example, a rigid TDMA system is not capable of such adaptation. It always needs to transmit and receive a certain period of time. And what is also important here is, due to our dynamic cadence and dynamic burst width, we can actually make use also of the periods when the offending TDMA system has nothing to say. Because, you know, even if they have 60% for downlink, 40% for uplink, it doesn't mean that 60% they are actually transmitting. Maybe they're transmitting just half of that, maybe just 1/4 of that. It all depends on the actual usage of the system, right? And we do not need to wait for them that 60% to actually complete. As soon as they are not transmitting, we can start our operation. So that is also beneficial when you are not limited in your timing. Now, let's move to the next slide. Sorry, not sure where that's moving. Just a second. Okay. The next slide, basically, in the end, the StarPlus system will be less degraded than TDMA rigid system, though still more than when it encounters CSMA-CA system. So we will get a bit more scars from the battle than when we are fighting for the same spectrum with Wi-Fi systems, but nevertheless, we will still be better off than the offending TDMA rigid system. But you need to note here one more thing, which might not be so obvious from the beginning. If, in my opinion, it is quite, let's say, risky to deploy a TDMA rigid system in an unlicensed band. And why so? In unlicensed band, you have no means how to regulate that everybody would be using the same TDD split, the same channel bandwidth. There's no authority that can enforce that. And if in the same area, two TDMA rigid systems would collide, it would, with different TDD split and different channel bandwidth, then the situation would be much, much worse than when StarPlus and TDMA rigid system collide. Why? Because two TDMA rigid systems with different TDD split and different channel bandwidth, they would basically completely cancel each other out, because they would always interfering, downlink of one would be interfering with uplink of another, and vice versa. Because they, if you remember the graphics from the previous slide, on the other side there's nobody who actually adapts. And when you have two rigid systems that are unable to adapt, they completely cancel each other out. So such technology is much, much more useful in the licensed band, but where all this is regulated. But in unlicensed band, TDMA rigid systems are really risky, since they are not well equipped to deal with the uncertainty of the unlicensed band. Now, let's go to the next one. Now, sorry, too quick on the mouse. Co-channel interference from TDMA system with dynamic timing. Basically, this means when we encounter somebody who is similar in nature than StarPlus. Doesn't necessarily need to be exact, because since the implementations of this are proprietary with different tweaks, different optimizations, it's highly unlikely the two systems would be exactly the same. But nevertheless, some principles of that dynamic cadence would make both systems to actually reach some sort of equilibrium. Basically, when you have both systems that are capable of seizing each gap and also dynamically adjusting their cadence, they will become similarly degraded. They will not cancel each other out, for example, two TDMA rigid systems. But after a while, both systems would become, let's say, approximately equally degraded, while both will still continue to operate, of course, with reduced capacity. They would, let's say, sort of effectively share the channel. But this doesn't mean that, for example, if only one system would get 100%, and when two are present, they would get 50-50 each. No, maybe they would get 40-40 each or 30-30 each. But nevertheless, both still function and the stability of connections will still be fine. So this is also at least theoretical possibility that can happen in an unlicensed band. So before we go to adjacent channel, I'd like to bring in some other thing. We need to understand that the EION's proprietary TrustLink technology, which is our implementation and optimization on the dynamic TDMA, is adaptive algorithm. This means that it learns over the time what conditions are in the field and it adapts to those conditions. It means that if you are, for example, measuring something in a certain point of time, in the beginning, let's say, it doesn't mean that it automatically does what's best course of action, but it takes some time to learn what will be the best course of action and then act appropriately. It doesn't mean that it's learning for a few hours, in most cases not even for a few minutes. Sometimes it adapts in few tenths of a second, sometimes it needs a minute or two, sometimes maybe even 5 minutes. But it's important that it needs to learn what the conditions are and adapt to those. We find this a very, very important thing in such an unpredictable environment as is unlicensed band. Now, adjacent channel interference. Any system operating in an unlicensed band, as I explained before, what we can encounter in the co-channel interference. Now I'll talk a bit about what sources of adjacent channel interference we can actually find in an unlicensed band. Let's say first possibility are self-caused interference from the equipment from the same vendor mounted at the same site. This is basically something that you are all familiar with also with the licensed band, and in the licensed band this was usually addressed with the synchronization. But here there are at least 3 more potential issues that we can find, and none of them can be addressed with synchronization. For example, interference from the third-party equipment at or very nearby the same site. Since the band is not regulated, anybody can do whatever they please to. Then you have interference from the airport or weather radar operating in proximity of, let's say, up to 20 kilometers. It's important to know that radars operate up to 5.7 to 5 gigahertz with extremely high pulses of energy. it goes up to 0.5 megawatt of EIRP. This is tremendous amount of energy, and it can knock any system out. It doesn't mean if they are 1, 2, 4 channels away from you, they will knock anybody out. Because the radios operating in unlicensed band usually have very wide, very broad bandwidth, maybe from 800 megahertz to 1 gigahertz, from, let's say, from 5.1 to 5.9, maybe from 5.0 to 6.0, something like that. So anybody can, from that spectrum, can actually, if they operate in close range, they can cause receiver saturation, and with that, interference, especially very high power source. In interference, when somebody's transmitted power is much below yours, then you have nothing to fear. But if somebody is within you, you're operating, let's say, sensitivity maybe within 3 dB or even above you, then you are asking for trouble. And that's the situation where you need to protect yourself from. Basically, EION's approach to addressing adjacent channel interference from all of the above sources at the same time is by use of strategically chosen block filters. This is the only solution that actually can take care of all these 4 different sources of interference. Of course, if none of the above is true for a particular site, filter is optional. For example, on some sites, you might use omni antennas. So you will have just one access point on one side. Maybe you will use just one sector on one side because you are not building 360 coverage. Maybe you will be deploying point to point, so you also have just one node on one side. Then you do not need a filter. If there is no third-party equipment nearby, then you probably also don't need a filter. If you are not in the neighborhood of airports or something like that, then you also don't need it. But in some places, like for example in India, in Mumbai, airport is virtually in the middle of city. So yeah, everything operating nearby needs a filter, and there's no other way to protect yourself from that radar. Now, just a second. So basically, what is our view on all this? Why we are advocating the use of TrustLink? Why we see this as so important differentiator from several other systems operating in an unlicensed band? Because it's effective against all variants of co-channel interference. It doesn't really matter whether the other offending system is CSMA-CA based or rigid TDMA or dynamic TDMA. We can face all of them, and we can coexist with all of them. With some, we would be very little degraded, with some we will be degraded a bit more, but no matter who we encounter, we are always able to be at least equally good or better. So why no synchronization, some of you might wonder. The explanation for this might not be so obvious, but you might got a hint from where I was describing what happens when you are actually encountering another TDMA rigid system. If one implements synchronization in an unlicensed band, it makes your TDMA system rigid in timing, and as such it is less effective against other systems, other rigid TDMA systems, other TDMA systems with dynamic cadence. Actually, you are, for a benefit of removing self-caused interferences on the same side, you are basically exposing yourself more to co-channel interferences that are not under your control. Our philosophy is that we are rather much better prepared against the unknowns from all different type of co-channel interference, and at the same time stay protected from all sources of adjacent channel interference. So that leads us to the next point, why block filters? Because they are the only protection against all sources of adjacent channel interference. Not only the self-interference, but third-party interference as well. Doesn't matter whether other equipment nearby or either radar or whatever. So basically, if we put these two things together, TrustLink proprietary technology together with strategically placed block filters, this will provide most complete solution for deploying a network in a harsh and unregulated conditions of an unlicensed band. Basically, that concludes my presentation. I have covered what are the conditions that one can encounter in an unlicensed band, and I also covered what is EION's take on all this, why our solution is very good choice for operating in an unlicensed band. Now, word back to Richard.
Okay, thank you, Dejan. Thank you very much for leading this presentation. I hope everyone on the call has learned something a little bit about interference mitigation techniques in the unlicensed band, and EION's approach to dealing with those techniques. If there's any questions, if anyone in the webinar has a question, you can post it in the chat session.